Hello class, this is just an extra video on solving even harder inequalities where there are two functions that we need to worry about. I've actually gone ahead and graphed what these functions look like, and let's see if you can interpret what the question is asking. Well, I hope you can see that it's actually asking where is this parabola less than this straight line. We can clearly see, or I hope in case you didn't see it, we can clearly see that from this point of intersection and this point of intersection, the parabola is less than the straight line. We know this because the parabola is below the line. And so all we need to do is just figure out what these x-intercepts are. Not x-intercepts, sorry. These intercepts are. So let's just solve as if this was a, what's it called? A simultaneous equation. Moving everything to one side, we get x squared plus 6x. 12 take away 4 is positive 8, less than 0. Factorizing this further, it's 2 and 4, x plus 2, x plus 4, and we get x is equal to negative 2, x is equal to negative 4. Now at this point, you could just use a table of signs, which is what I'll demonstrate to you now. So let's just pick values, negative 5, negative 4, negative 3, negative 2, and 0. Remember, it doesn't need to be exactly one above, so long as it's above the value. We know that negative 4 and negative 2 are 0. Now it's just a matter of figuring out these values into this one here. So negative 5 into here is negative 3, negative 5 into here is negative 1. Two negatives multiplying is positive. I hope now you can see what the graph looks like because we have the x-intercepts. 4, negative 2, doing something like this. Well, here's positive, which means that it must be negative in between, and this must be positive. So now that we have this, we can see that by moving everything to one side, the problem becomes just this inequality. Now it's asking where in this inequality is it less than 0? Well, we can see between negative 4 and 2, it is less than 0. So x is less than negative 2, but greater than negative 4 in bracket notation. There we have it. So this actually coincides with what the graph shows. So this means that this is negative 4 and that's negative 2. And it's saying that this parabola is less than this straight line or below the straight line from negative 4 to negative 2. If we go beyond negative 2, we can see that the parabola is bigger or above the straight line. And same goes for here. Anything to the left of negative 4, the parabola is now above the straight line. So let's just solve this last question here. Moving everything to one side. So now really all we're looking for is this x-intercept because it's asking where is the green parabola, this one here, where is it greater than this orange parabola? Well, we can see that from this point here, this point, the parabola is bigger than the orange parabola. Whereas this point here, the orange parabola is bigger than the green parabola. Now there are some misinterpretations here. A lot of students tend to think, oh, this is bigger than this part. But if we were to extend this parabola here, we can see that the parabola, if it's extended, is bigger than this green parabola at that point. So really we want from this point to the right. Well, just a matter of figuring out what that intercept is. So here we go, just moving everything to one side. These two cancel. 7x minus 5x is 2x. 12 take away 6 is 6. Is equal to 0. We can solve this. X is equal to negative 3. So that point there is negative 3. And without using the table of signs, we can just say that everything to the right of negative 3, the green parabola, is bigger than the orange parabola. So we can just say x is greater than or equal to negative 3, or in bracket notation, negative 3 to positive infinity. So I hope that gave you an insight further into interpreting graphs and what it means and what inequalities mean in terms of the graph itself. So hope to see you in the next video. Best of luck.